All right, let's dive into a really core piece of network security, access control lists, or ACLs. Now, you can think of these as the bouncer and the rule book for your network. They're the ones deciding who gets in, who gets out, and what they're allowed to do once they're there. So let's get into it. When you boil it all down, network security is really about answering this one question. You've got your cozy, trusted network on one side, and then you have the wild west of the internet on the other. So how do you build a secure gate between the two? Well, that's exactly the problem that firewalls and these ACLs were created to solve. So here's the game plan for this explainer. First, we'll look at how things work by default, right out of the box. Then we'll get into building our own custom rulebook. After that, we'll see those rules in action with some real-world examples, pick up some pro tips to work smarter, and finally, we'll cover how to figure out what went wrong when things don't work. So what happens the moment you power on a firewall, before you've even written a single custom rule? You might think it's just wide open, but it's not. It actually has a default line of defense, and it's all based on a pretty simple concept of trust. Firewalls think in terms of trust levels. For example, your internal network, your inside, that's a high trust zone, let's say level 100. The public internet, the outside, that's zero trust, so level 0. By default, traffic is allowed to go from high trust to low trust. Think about your computer going out to a website. But any traffic trying to come in from that low trust outside world is automatically blocked. It's a solid, safe starting point. But what if you need to host a public web server? That's where this default system just isn't enough. And to get that really specific, granular control, we need to build our very own rulebook. And that is the access control list, the ACL. It's what lets us override all that default behavior with a very precise set of instructions. The smallest piece of our rulebook is the access control entry, or ACE for short. Just think of it as one single, specific instruction. For instance, allow web traffic from this specific computer. Each ACE is just one line, one command in the list. And when you stack a whole bunch of those ACEs together, well, then you have an access control list, the ACL. This is the complete set of rules, your entire security policy for that part of the network. It's the full rulebook, not just one sentence. Okay, this right here is probably the most crucial thing to understand. The order of your rules is everything. When a little chunk of data, a packet, shows up at the firewall reads your ACL from top to bottom. The very first rule that matches that packet gets applied, and then the firewall stops looking. That's it. This first match wins idea means you have to think strategically, always putting your most specific rules up at the top of the list. All right, enough theory. Let's see how this stuff actually works in the real world. We're going to build out a few simple but totally essential rules to get our network traffic flowing exactly the way we want it to. So our first task is a really common one. We need to allow ping. Ping is just a basic network tool that uses a language called ICMP. It's how one machine can check if another one is online and reachable. It's basically like shouting across the room, "Hey, are you there?" We want to let that simple check happen anywhere on our network. So here's what that rule looks like. The action is permit. Simple enough. The protocol is ICMP. That's the language ping speaks. We're setting the source and the destination to any, because, hey, we want this to work from anywhere to anywhere. And finally, we apply it globally so it affects all traffic. See? Simple, clean, and effective. Okay, let's try a more specific rule now. Traceroute is another cool tool that shows you the exact path your data takes to get from point A to point B. Now, we want our internal users to be able to use it, but we definitely don't want random people on the internet tracing a path into our network. So this means we have to get specific about the direction of the traffic. So to pull this off, the rule has to be a little more detailed. The protocol is UDP, and it uses a specific range of ports. But the real magic is in that applied column. Instead of globally, we're applying it only to traffic coming in on the inside interface. What that means is the rule only kicks in for traffic that's starting from our trusted internal network. And that's exactly what we wanted. Look, creating rules one by one is fine when you're starting out, but as your network gets bigger, that list can turn into a real monster. So now we're going to look at a couple of techniques to keep your rulebook clean, efficient, and way easier to manage. So let's say you want to allow basic web browsing. Well, that's really two things. You need port 80 for regular old HTTP and port 443 for secure HTTPS. The old school way to do this would be to create two separate rules that are almost identical. I mean, it works, but it's not very elegant, is it? The much smarter way is to use something called an object group. This basically lets you bundle similar things, like our HTTP and HTTPS services, into one container that you can give a name to. Then you just write one single clean rule that points to that group. And the best part? If you ever need to add another web service later, you just update the group, not every single rule that uses it.
And here is a fantastic tip from the trenches. You know, sometimes you get a user who needs access to something right now, but they don't have the exact security details you need. So instead of making a permanent rule that's way too open, you can create a time-based one. This little time bomb rule gives them temporary access, but it expires in, say, 24 hours. That's usually all the motivation they need to get you the right info for a secure, permanent rule. It's a great trick.
So you've built your beautiful, efficient rulebook. Everything is neat and tidy. But then, the phone rings. A user can't get to a website they should be able to. How in the world do you figure out which one of your amazing rules is actually the problem? This is where a tool like Packet Tracer becomes your absolute best friend. It's a simulator. You basically describe a piece of imaginary traffic. You tell it the source, the destination, the port, and it runs that virtual packet through your entire firewall setup, including all of your ACLs. And then it tells you exactly what would have happened to that packet and why. It's like a crystal ball for your network. And here's what it tells us. We can see that traffic from our internal network going to a public address was dropped. But the reason column is the most important part. Implicit deny rule. This is the invisible, unwritten rule that lives at the very bottom of every single ACL. And all it says is deny everything else. So if your traffic doesn't match any of the nice rules you wrote, it slams into this final wall. Packet Tracer makes finding these kinds of problems incredibly easy. So now you get it. You know the rules for building a secure network. The logic is pretty straightforward. Permit what's absolutely necessary and deny everything else. But the real challenge isn't just writing the rules. It's knowing with 100% certainty that they are working exactly the way you intended. Because when it comes to network security, what you don't know can most definitely hurt you.